Hi everyone, welcome to our first lockdown online event. Hope everyone is safe at home. We've come a long way to get this event going, so I hope everyone will enjoy it. Those that's not familiar with what MSDUG is, it's the Microsoft Developer User Group. What we focus on is basically any sort of development, so any developer topic is welcome, as long as it touches on Microsoft technologies somewhere along the line. We've come a long way to get this event going, so I hope everyone. Let me just mute. Okay. Right, the year started off brilliantly. We had the Microsoft Ignite conference, and we brought all our user groups together. So we have a Microsoft Developer User Group in Cape Town, Durban, and Joburg. You'll see the logos there on the top of the screen. We had a united front at the Ignite conference, and we had a stand that featured the developer user community. We also had speakers. Homo was a speaker as well, and Johan as well, which is organizers of our events. So that was the year starting off as a bang. It was going to be a great year. Then things didn't quite work out as well, but hopefully we can get things going again with our online events. Okay, so our next event that we had, which was a major event, was our hackathon. It was basically an AI and IoT hackathon. It was run in Cape Town in March. It was based on Raspberry Pi's IoT Edge, and it was all about building things and having fun. We managed to have that event in Cape Town, but unfortunately our Johannesburg one was cancelled due to the COVID virus. So hopefully we will have that event again soon, and we have another one planned for Cape Town, which will involve building a little robot, intelligent robot. It will have we will integrate it with Xamarin, so all the Xamarin fans hope that will be a good one for you. It will feature Bluetooth, low energy, and we will make like little fun little robots and things like that. Right, so then we moved on to May, and with this COVID virus, we were moving, all the events were moving online. So Microsoft moved their big developer conference, Microsoft Build. So that was held in May, and if I'm imagining most of the attendees of this event attended the Build virtually, but if you don't, or if you didn't attend, that link at the bottom, which is the news from Build, it's a very, very good place to see all the cool stuff that happens, because Build is one of those conferences that gives you all the new things that happen, always under wraps at Microsoft, and that's where it's announced. So that book of Build is very, very good. So we're not here today to listen to me speak. We've got some awesome speakers lined up. So this is our, as I say, our first lockdown event. It's our first online session, so do bear with us, because we're not really used to this. All our meetups are in person, so we have absolutely no idea what we're doing. So hopefully that doesn't show too much, but bear with us as we go along. So we're starting the day with Matthew. Matthew's going to be speaking to us about putting GitHub Actions into action with Xamarin apps. Antonio is going to be giving us an introduction to AKS or Azure Kubernetes services. And then Matthew will be back with the COVID Xamarin exposure notifications implementation, which is quite interesting. Unfortunately, we had to cancel Pavendran's talk. Pavendran's talk was on GitHub pages. He had a medical emergency of some sorts. Hope he gets well soon. I think he is attending and he is alive, so, but I hope you get well soon, Pavendran, and we'll see you maybe at the next event. Okay, so that's happening today, but part of this intro is also giving you an idea of what's coming and what else is happening in the communities. So in June, which is next month's event, we're going to have Lauren beaming in from Europe. He's going to be giving us a session on debugging Azure apps in production, which should be really interesting. And then we have Karika, which is going to give us some information on a really cool presentation on mixed reality apps using Power Apps. So it should be really, really cool, that session. Then Homo will be giving us a Blazor app overview using custom vision. So all the .NET people out there, that's definitely a talk to not miss. Some of the other events that's happening, the Remote Resilience Online Hackathon, that event is happening across the whole of the MEA region. So in other words, Middle East and Africa. It's a huge hackathon. It starts in June. So if you're very interested in hacking and the prize money, I think the top prize is $4,000. If you're interested in that, have a look at that link that's posted on the screen. Right, and thank you very much. That's it for the intro, and I'm going to hand over to Matthew. If you do want to speak at these user groups, we have a sessionize. There's 2 sessionize links up on the screen, and you can either submit in Cape Town or Johannesburg. For these consolidated events, either one of those will work, but feel free to submit. Everyone has something interesting to say. And thank you very much, and over to Matthew.
Hello, are things happening? Whoops, everything disappeared. No, why does it do that? Think I'm back, I don't know. Say visual feedback. Okay. The chat's gone. Anyway, I'm gonna assume it's all live. Allan will tell me if it's not. Absolutely no visual feedback. Where's the chat gone? Yes, I'm live. Yay! All right. How's everyone doing this cold evening? I had to put the heater on because my fingers were so cold and stiff that I couldn't type. Anyway, I'm Matthew, as it says on the slide that you can see. I'm a software engineer, and I have a handle there. You can get me on Twitter, Instagram, or GitHub, just in case you want to check out my cool photos. But anyway, I'm a big Xamarin fan, and I wanted to talk about just sort of share like building Xamarin apps with GitHub Actions. I don't actually know GitHub Actions. Well, I know it now. I didn't know before I started, so I was like, let's pick a topic that I haven't done before. I haven't really looked at it, and I thought, let's pick that and let's throw Xamarin in there because I have to get Xamarin in the slides at some point, and I'll make sure that's focused so I can go to the next one. Right? Yes, Xamarin. So let's have a quick intro at Xamarin. Just in case people don't know, but just going to give it like a quick intro into what it is, what it does, and why it's the greatest thing since sliced bread. So first of all, what is Xamarin? Well, breaking news, Xamarin is dead. As for the guy in the back of the user group always says, is it dead? Yes, it is, because it's a new thing. And yay, it's .NET for Android, .NET for iOS. Xamarin is just a name that we hold dear in our hearts. But what is .NET for Android and iOS, or Xamarin as it's known by the monkeys behind me? As you can tell, they've all come to be a part of the talk. It supports cross-platform development using the .NET framework, or in the case of the new modern world, the .NET Core libraries, or the new .NET 5 is going to be coming soon. It's cross-platform development using languages such as C# and F#, and well, it used to be Visual Basic, but Visual Basic is also on the sort of the low down now. But yeah, it's a cross-platform. You basically, in some cases, it's a write once, run anywhere situation, and that's always cool. We're working on an app for the exposure notifications for just in open source, and that pretty much is 100% a .NET app. And there is like 3 lines of platform-specific code for Android and iOS, just because we have to use like a certain feature that's just not really worth putting into a shared component. And that's really cool. And we're even sharing things between servers and clients, such as the Azure functions we're using, as well as the Xamarin/.NET for Android and iOS mobile app. So that's really cool. I really love the sharing possibility. And if you want to find out more about Xamarin, you can follow that link. I'm sure at one point it's going to be /app/mobile, but for now it's /Xamarin. You can go check out that. But I've got a cool little graphic because I love throwing this in there. .NET, the little purple block at the bottom, or sad and alone. Not really, because he has all his friends above him. So whether it's mobile, desktop, web, cloud, gaming, it all works running .NET. .NET works everywhere, and pretty much if .NET works everywhere and your code is .NET, that means your code works everywhere. That's pretty cool. And like not only reusing skills and tech, it's just a really awesome language, especially with the C#8 and now the C#9 coming out later. Really cool features. Definitely go check it out. And today, even though we're going to talk a little bit about everything, we're going to focus a little bit more on that cool little Xamarin logo, little Windows, Apple, Android, and then of course there's the .NET little bot. So it's going to be fun. But onto the main topic, GitHub Actions. And what are GitHub Actions? Well, as I just said, the Xamarin in the case is .NET, Xamarin.NET, sort of the whole system is building awesome apps using an awesome language. Well, GitHub Actions is sort of the final part of that, is helping you automate the process of building that app, whether it be features such as just running a compile check to see if your code actually is valid, or it'll be publishing or testing or deploying or just anything really. It's a way in which you can use YAML to basically describe the steps or process you want to follow, so that when you check in your code, it runs this automated tasks of making sure that what you checked in was pretty cool. You don't want to check in some bad code and nobody knows until you release, and then master doesn't build because some reason. So we can have a look at some of that today. I'm going to show off 1 or 2 workflows and examples of building, testing, deploying, and all the cool stuff right from the GitHub and that stuff. If you want to check out some links, I've got some links on that slide. The slides will be shared later. I'm not quite sure the process of sharing slides during one of these things, but I'll send it. But it's basically it's github.com/features/actions. You can learn lots more about actions, and hope you get started right away. So let's see, what am I talking about next? Yes. But before we talk about code, I just want to reiterate one of the most important reasons for automating this. Sure, it helps you, I don't know, not have to right-click publish from your desktop. And that's not really automation. That's just the benefit of automation. But automation, the real purpose, for me at least, behind it is that sort of what do you call it? Like that sort of safety net, if you will, because when you check in your code, there's a compiler on the cloud that is not your machine, is going to be running your code. It's going to compile it, make sure that the project files are correct, the dependencies are correct. It's like the most minimal step that you can possibly do. If it's a .NET app, it literally can run MS build. That's it, and that will make sure that the code is well, it runs it, that the NuGet packages restore, and even though it's like you might have a complex project, there's often all that is required to get you, my colleague checked in a code, he did a merge online, or GitHub merged incorrectly, and now the build fails later on down the line, and we don't know where it happened and whatnot. And it's just basically when you make a PR or a commit, it'll be right there at the bottom saying you're good to go, and you can commit that with confidence, knowing that you're good and green. And it's not just running MS build. It'll be analyzers or linters for if you're using like JavaScript or stuff. It's definitely a way that can save your life. Not quite, but when you're working on a large project, especially when you have more people involved. And this is not just building. It's for like, well, let's extend this idea of running a step for tests, where it'll be like, oh, I just want to test to make sure that the assembly can be loaded. So you just instantiate a random entity from your data access layer. It doesn't have to talk to the database. It doesn't have to do anything. So definitely automation is something that, again, makes sure your code works, makes sure your types work. And you can even go and say, like, you know what? Let's set up a fake in-memory database and check that data access layer. It is not so hard. We've got lots of tools out there, and sometimes your project needs to be massaged a bit to get it to work really awesome in a unit test environment. Hopefully everyone is using unit tests. I'm just going to assume that at least one unit test, even if it's a fake empty unit test. I mean, I just expect that now, because if someone makes code that changes behavior, either good or bad, you want to know about it. And unit tests running on a commit or a PR to your source code is just like the most essential things. It's like, don't store your code in Dropbox. It's a cool feature for sharing photos. Don't store your code there. And when you store your code on GitHub or other source control, you're running automation. Just run the tests to make sure that you don't have to run all the tests. You don't have to run everything. Just run a subset of spot checks to make sure that you haven't done something hideous. Because the worst thing is 6 months down the line, you're doing a major release and nothing works because it all stacked up and all the developers were just testing a feature. And talking about releases every 6 months, if you're running tests every time, your integration's passing, your builds are passing, you might as well just release to a preview feed, every week, every 3 weeks, whatever your cadence is. That's how the previews for like Visual Studio works. We get 3 versions out a version out every 3 weeks, and feedback instant. You can add a little feedback button. You can have a website for feedback, and if you get your feedback within like 3 months, or not 3 months, within 3 weeks of a release, right, you can fix that so that the next release is better. And that is the power of automation. Your code's good, your code works, and it meets user expectations, whether it matches the buttons are in the right place, the functionality is correct, whatever. And this is all brilliant because you just automated the task of getting the package ready for release every time. And then when you have to release, I say, wait a minute, this package has been out for 3 weeks already. Might as well just go stable. And you push that button, and boom, you're stable. No stress. There's no such thing as don't deploy on Fridays because you deployed 3 weeks ago. So me rambling on about automation. I've seen hideous acts of Dropbox storage. I've seen it. It's terrible. Probably other people have seen worse, but at least use source control and automate that source control, and then you can focus on becoming the awesomest developer there. So enough rambling about automation. Let's go back to specifically GitHub Actions. What is cool? Well, one of the really cool things is it's not just .NET code. It's literally when something happens to your code base, you can do something else. And in the case of a Xamarin app, it'll be a build and a publish maybe. In the case of a website, it could be a build and a stage. It runs any task at anything. And this is like, if someone creates an issue, you can react. If someone does a PR, you can react. And you've got a way to say, hey, when this event happens, do this thing. And what is really cool is I'm going to show you later is if you have your code always building, but then you can just say, oh, I'd like to release. Just tag your build. It'll tag it, take the version information, stick it in the NuGet package, and push it out to NuGet.org. Because first of all, your package works because it built on master and the PR. And the tag is just like, specify the version information or something. And it's really awesome. Builds, release, tags, PRs. It's all ways to trigger a workflow. And you don't have to worry about, where is this running? How is this running? You're in full control. You choose your language. You choose your tool chain. You choose your runtime. You choose your operating system. You choose everything, and you run it. In fact, it's just building anything because you have absolute control. And if it comes to the crunch, you literally got the shell, whether it be PowerShell, Bash, command line, or CMD, and you can run that. There is no limitation. And you could say, I would like to run this set of jobs or set of tasks and run it 5 times with different versions of Node or Python. Let's say you're making a Python app, Python 2 and Python 3, make sure your code works. It's no longer, I have to copy paste this entire workflow and change one little number from 2 to 3. You can run it on Python 2 and 3, and then, hey, wait a minute, Windows and Linux and Mac. So you can have 6 builds pop out of a single tiny little workflow file. So it's just amazing stuff. When I started with this, I was like, yes, I'm switching all my stuff to that. And of course, variables, secrets, conditions, expressions. It's not just like some basic YAML. You can do some pretty complicated stuff. So that is really exciting. But let me hop over to another interesting fact that people always talk about: money. Money is important to people, especially when you are in an open source community. You're not always churning in the big bucks, but also if you are a company and you want to manage, make sure you're not wasting money, because you're spending lots of money on all the Azure services, which I hope everyone is, because Azure is the greatest cloud, not because I work for Microsoft, but because it is. Open source is free, so if you've got an open source repository, it's free out the gate. And if you're a closed source company, enterprise, secrets, and you want to build something for free, just make an open source library. The community loves you, and you get free stuff. So that's one option. And if you've got a massive corporate that's churning out the big bucks, you don't need to use the free one. You can obviously take advantage of several levels of money, which you can check out the pricing things, and you get different levels, and you get more features, more build minutes. And finally, who cares? Just bring your own machine, and you don't have to pay anything again. So that is, of course, the really awesome thing. And if you want some secret government software to run somewhere, you don't have to worry. Just install it on your own network. Possibly at that point, you've got your own local instance of GitHub. All this stuff is really awesome. So it's really cool, especially with the open source, and there's lots of levels to work up. So before I go to code, I thought I would show a nice big slide of what is a GitHub action. Rather than doing each step, is what GitHub actions are. We really care about how to use them. So the way you use them is, I said earlier, with a YAML file. And let me get my little spot thing out, the laser pointer, and let's just move this. Yes, there it goes. So basically the simple YAML, this is a slightly more complex YAML because there's like multiple ons and jobs, but basically a very simple YAML is basically you give it a name because that's some sort of cool user-friendly name you want to do, whether this would be like build it or test things. It's totally free for you. This appears in the checks at the bottom of a PR. And then we get to the next section as we were talking about the events. This is an on a push and pull request here, but this is basically anything that you want this workflow to run on. So in this case, this particular source builds on a push to master and a push to the a pull request to master. But you can totally replace this with as I said, like, when an issue is created, when a commit is done to a certain one, you can have the commits being filtered. So this is just a little way to say, okay, I want this code to run on a push to master. And what does it do? We jump down to the jobs section, and let me move that a little way so I can see my own screen. The jobs, there's lots of different jobs. You can have jobs that run in serial and parallel, which is really cool. And basically the way the jobs work is you say, give it an ID, which is in this case I've done build. You can call it whatever you want. I want to run on Linux, Ubuntu latest, and these are the steps I want to do. And the first one is a cool one from Actions. There might be some cool ones you can just pop right out the gate. Check out the code in this case. No parameters, just I want to use the action of checking out. That's it. It checks out the code. Then the next step is one you can add parameters. In the case of this one, it's setup.net, and you specify the .NET version. And a lot of the cool actions do this. You'll see in my YAML, it will set up Xamarin bits. It sets up, MS build the way I want it. And it's a couple of lines. In the case, it's setup.net, and you want to use it with, which is the case of the parameter name they use, and the .NET version of 3.1. So that does some stuff, and after the step, .NET is set up. And finally, if you want raw power, you got the run command, and this will run some sort of shell bash command line PowerShell, and it will literally execute this very step for you. And that's it. This is like a super awesome way of, when someone checks in code to the master branch, just build this app on Ubuntu. That's what it does. It's super cool. So let's show some actual code. I'll start off with one that's simple than that. Yep, that's right. This clicky stuff. Let's hop over, drag this window. Wait, no. Go across. Oh no, come on, little one. Here we go. Hope the font's big enough. Made it nice and big and exciting. So in this particular project, I have it's on GitHub, and I'll share the link after it as well. I've got 3 separate apps here, so that's why there's 3 folders. I'm assuming it's big enough. Someone's going to have to say, yeah, it's big enough. So there's 3 apps: a console, a library, and a mobile app. But it doesn't matter. You can have any sort of thing. This could be a massive monolithic one with 100,000 folders. So it doesn't really matter. In this case, instead of having 3 repositories, I stuck it in one, which also allowed me to demonstrate a really cool feature. So let's take the simplest of all console apps. There's a nice little app. It's 3 files, a solution file that links to a project. This project is the minimalist as you can get, and it literally writes hello GitHub action world. That's all it does. So assume this is a massive tool that your company uses. Just put 1,000 files in there. How do we build that? Well, let's just jump to the console one, which I did. And in the case of this, I got a big YAML file. And let's just pop the zoom out one more. No, control shift minus. There we go. So you can see the whole thing on the screen. So let's just start at the top. I got a cool name, which I'll show you in a second what it looks like on the UI. In fact, let's just be really cool. Let's stop this. And then let's pop up the web. So this is the right page. And no, right, there we go. No, across, there we go. Side by side. UI jigging. Nope. Ah, come on, no. It's advanced Windows manipulation. Look at that, it's showing all the both screens. It's like, wait, where's my privacy? I mean, I'm trying to look cool here. Let's minimize that. And we want to look at, so here's the GitHub Actions, and the case of, well, let's go to our existing pull request, which doesn't seem to work now. You know what? Make a new one. So in this case, I've got a build for the console app, which if you look at the status here, there is the build console app, and this was on the push, which was this push over here. And obviously there's other ones on the pull request, which I'll show you in a second. And when I push to master, I want to build this workflow. This is for the, I'll show you, talk about the filter in a second. And what are the jobs I want to do is I want to build the app and I want to run the app because I want to test it, because this is one way to do tests, just run the app. And it runs in a virtual machine, so you don't have to worry about breaking things. Make that a tiny bit smaller. So very simple. I've got cool names for all my steps. Let's just step into that actions. So here's my steps that I did: the setup, checkout, setup.NET Core. Here's checkout, here's setup.NET Core. Very simple. And if I do checkout, some stuff's going to load when it loads. And basically what I ran was the GitHub action checkout 2, which I got over here, and it checked out. Now setup.NET Core, the exact same thing. And this is really cool. It's just a whole bunch of actions, which I'll show you in a second, all the actions you can get at. And I set up .NET, I do a .NET build, and this you want to check, oh, is this the real .NET build? Yes, there's the whole .NET build, setting up some telemetry, and then you run this command, it ran that with some variables, and here is the massive output of, well, it's a short one because it's minimal, and here is the DL out ran up. And then of course you can do like things like publishing, right? So I ran a .NET publish. In the case of a console app or a WPF app, you can publish that, and there's steps to add it in an M6 package. Here's .NET publish running, and of course you can upload to artifacts, which I do over here, and it pops up artifacts over here, and there it is, the console app. And that is just this tiny little bit of code. I make it extra because I like the cute names, so build app, checkout, setup. But this is like 4 or 5 lines to entirely build, publish, and upload it to the thingamajig. And then, of course, just to demonstrate the cool things, you can build it and run it. This second action or job is one. And if you look on this one, I build on Ubuntu, and I like, oh, I want to run on Windows because that's the way we roll. And I set up a dependency. It needs build. And we do some other steps. And in this case, downloads, it builds and runs, and then you'll see hello GitHub Actions world. And that's really cool. It's very minimal. It's not super invasive into your code. And this is what someone would do manually in a script file, maybe during a release process. So you could technically take this zip file, download it, and distribute it via network share if that's the way you roll. And that is really cool. And this is now a simple example. It does some simple things. But with the pull request example at the top here, if you look at my workflows, I have lots of workflows, and a lot of these are building mobile apps, and they take forever to run. If you look at the mobile one, the Android one, I think it takes 1 minute, but the other step, basically 2.5 minutes to run this. But what happens if you change one line of code in the console app folder? You can use a filter, and I can show you that right now because it's cool, and I must totally watch my time because I always let's just zoom that out a bit. Let's scroll bar. Let's go in here and I edit that, and we're going to slap. I should do like a code spaces demo, but not for now. So we're going to commit to a branch. We're going to call that dev, and we're going to. Oh, the room's getting cold. I must turn my heater on. It's chilling my fingers, people. Let's do test. No, let's do live. Let's do that. That's where we roll. Propose a file change. So obviously all your developers are working on GitHub on the web. Nobody uses IDEs anymore. Pretty much. I should probably check that. You know, I could have done a live. I could have made this even bigger demo. Whoa, code spaces. But whatever. And of course, look over here. It's just running the single
next
job.
time.
Yeah, next time. Yes. Yeah. Basically, and there we go. This particular workflow has run, and it just ran this one, and not, for example, the library, which is set to filter on the library, and not the release and the mobile app and stuff. So really cool that that thing works. And look at that, it's done. So let's drill into this awesomeness. Oh, it's building the next step. So the first one, I did the build, I did the publish as we expected it. Really cool. And it's going to run the run, which is basically going to download the package, set up .NET Core, which takes probably going to take longer because the Windows ones aren't as fast. But that's why you bring your own device and you put on that nice Cray computer. I don't know if Cray computer support running .NET. I don't know if that's a thing. Like, do they even have normal CPUs? Anyway, you would get your Xeon CPU server rack that you had originally in your office, but then you moved everything to the cloud and off premises. And you're like, what am I going to do with this massive machine you paid 100,000 Rand for? Well, simple. You turn it into a build machine. And of course, when it runs, so download the thing and come on. At some point, it's going to complete. But anyway, so that's really cool, really simple, just a basic build, and there we have it live. And of course, let's just show the other cool factor. It's all green. I can squash and merge because I like to squash and merge, and we delete. And now when we go to this particular one, as you can see, it's building all of them because I set up the job. When I do a PR, build the subset, just the console app. But when I go live, if you look at the library app, it also builds on the subset, but also on a push. And that way you can sort of secure your main branch. It's like, oh wait, your PRs, let them be quick and nippy so that you don't hold up a merge thing. But then when you merge, you could also do this on the PR. But let's say you want to do something cool, you can say on a merge, build everything, make sure it's all green. And if something goes wrong, you can always roll back or whatever. So that's pretty cool. That's .NET Core. I better show some Xamarin stuff, otherwise my title's a lie. So here is a cool example of a similar startup running on a branch and a pull request. But over here, I am building a .NET Xamarin cross-platform library because that's my world on which I live. It's a very simple app. Let's show multiple pages here quick. Come on. So it's a simple project. It builds with .NET Standard, iOS, Android, and Tizen. And of course, when you're building on Windows, add Windows to it. And I want to build a NuGet package. So it's pretty simple. Obviously, right now it does absolutely nothing. Should have put some code in there to be cool. And let's just say you're making a library. This is totally useful for enterprise. You want to share across all your hundreds of thousands of teams and projects. Well, you can also use an actions to build on. Say I want to build a Mac. I want to check out. I want to set up Xamarin. And this is an awesome example of a community action. So you can say, hey, when I run this thing, use the latest iOS, or you could specify like iOS whatever 13.3.290, whatever the Xamarin iOS version is, or your Xcode. I want to use Xcode 11 because that's what the cool kids are using. And here is a basic, once again, just a raw MS build step. You could use an action to do MS build, but honestly, I mean, that's just more lines of code to write. We're all lazy deep down. And this thing is, so this is a builder library, And then when the build is done, or in parallel, actually, in this particular case, I build the NuGet package. So this just checks the Mac build works, because my main system is the Linux one, and that's going to build the package, set up whatever Windows needs, the MS build path. It runs the NuGet pack, and I've got some cool stuff. You can access variables, which will be, in the case, where's the source code located, and I'll talk a little bit about one like that, but I'm probably taking too long. Here is some example of conditions. For example, when someone pushes to master, you don't just have to filter at the top. You can actually filter inline, like, oh, only run this push to the NuGet, to the GitHub packages repo, whatever, feed, and so when I push to master, push that to the feed. And next to that, we also want to run the tests, and that obviously is just using .NET tests. So again, really cool. And if I go back to a previous commit, just to show you the exciting stuff, if we do new things, as you can see, lots of trials, trial and error. So here's a library push. Let's go to there. And as you can see, here's the steps. So we've got the build the library. Let me move that to the side. We've got the build the library. Okay. Then we got the build NuGet package, and that's nice. We have it here. It's doing the path stuff. And then finally over here, we've got some interesting matrix thing. This is sort of what Neo was using, obviously. And some more variables using, which is pulling a variable from the matrix. It's like, oh, I want these two things. Basically, as you can see, I duplicate the task based on the matrix parameters. And so I run the tests on Mac, and I run the test on Windows. And the setup Xamarin was skipped, because if you look at setup Xamarin, right, I only run it when the OS is Mac OS latest. So it's super easy to control exactly what you want to happen. And then quickly jump into mobile before I totally run out of time. Again, I want to build mobile when I commit to the mobile things, but when I merge to master, build everything. That's nice. Got a cool. I set my default shell, whatever. That's nice. And then I've got some exciting passwords and secrets supposedly coming up here. No, secrets, not yet. Not yet. Don't release the secrets. So again, I set up Xamarin. I use MS Build to build my Android app. This is totally what you can do with the command line today. No special features. And I choose my target because I've got full power of the command line. I build it, it pops out that APK. I take that APK, I zip it up and upload the artifacts. And if I go to build NuGet package, no, come to me. And there we go, you can see the iOS and Android app. And these are just normal zip files, and obviously something failed. And that doesn't matter. And you can check the workflow file. And in the case of iOS, because I'm building a release version, I need to have my provisioning profiles and stuff. So I've got, let me show you my secrets. There we go. I've uploaded the secrets for the repo. This is cool to put in here, or I think you can put them at the org level as well. So you can share your secrets. In this case, I've uploaded a base 64 GPG of my thing. So I take my provisioning profile. In this case, you can do whatever you want. You can Azure Vault, Key Vault or something. Take my provisioning profile, I run GPG over it, and I base 64ify it, and then I just copy and paste it into basically the text box here. And boom, I've uploaded a secret. You can obviously use whatever secret you want. I've done the easiest one. I download the secrets, and I use another community action to install the secret into a keychain and put the passwords and stuff, and therefore I can now build an iPhone release package which will pop out a .app. In the case of the IPA, to go to the store, because I chose not that, but you got this app and someone can come along and inspect it on the iOS in here. Really cool. And this is pretty much, you've got a Xamarin app building. So I thought one last thing. So that's cool. That happens on the build. But I thought, you know what? Let's show off something else you can do, like on a tag. So let's go, when you tag a release, right? When you create a release, like over here, I created a V1, and you want some cool stuff to happen. Well, in this case, I actually push out. You look over here, push to NuGet, and this is something that you can do when you say, my project is ready to go. Push to your internal feed. Say you can tag a version and all the stuff lines up, and you can pull values out of GitHub to find out when it was committed, what's the version number, what's the release name, what's the commit hash, all that sort of thing. And I got it. This was totally deployed live. In fact, if I go over here now, it should take forever. I've got no self-control actually. It's probably going to fail because I can't push another V1, but let's not do that. It's hand off the mouse, hand off the mouse. Anyway, so you can push out, you run MS build and you push the NuGet, and this is really understandable for those who have been doing NuGet push as well, because literally it's that. And yeah, and of course to set up NuGet, I set up NuGet and I used the token, which again was found, the NuGet token, which I created on the NuGet org website. But let's talk Xamarin again, because even though that's packages, we want to talk Xamarin stuff. So again, I run a release on a publish. So on that particular release, I ran this job again, which runs on the publish, and this one distributes the Android to App Center because I want to distribute it to all my collaborators. Okay, so in the case of the in the case of the key store, again, I've base64'd it and I've uploaded there, because who wants to do Azure Key Vault, right? Why pay for something when you can get it for free? So I base64 my key store, I upload it there. I literally get the bytes, download it, save a file, and then I use it along with other passwords as part of my my signed package, right? And this pops out a fully distributable key store verified, what you may call it, into the output directory. It's absolutely awesome. And then I take that, I copy the signed APK, I pop it into App Center. Look at that. I was looking for the next step. This next step is really, it's how simple it is. It's literally, if I take out my OCD type of I have to name everything, like just do that, run that, and like that. And obviously, I like these multi-lines for these ones because, so it's basically a checkout, set up Xamarin Android, download the key store, build the thing, and publish the thing. I mean, it's 5 steps. It fits on one hand, and that is just how easy and simple it is to do an Android app. And like, oh, it's not some weird thing. It's literally going to the same pipeline that you've done on App Center. You get all the features, and it's just super easy. And I love it. I'm going to switch from Azure DevOps. Sorry, Azure people. I think this is cool. You can do most of the same stuff, but the fact that this lives with my code and it's built by the same tooling done in the code makes it really cool. And you get access to all the things such as on a release. And I can even just hop straight on here. I've totally collapsed. I should have been back by the slides and everything. It just doesn't matter. We're winging it. So that's cool, right? We've seen all this cool code that does a build, a distribution, and testing, and all that cool stuff on a commit. But what happens if you want to do more? Deep down, you want to do more. I don't know if I was looking at the camera. I'm winging it now. Greetings. So this is another cool example. I hear sounds. What's that?
That was me.
Is that Allan saying, Matthew, keep to the schedule. It doesn't matter. Can't control me. So basically, here's another really cool example of nothing to do with code, but to do with like issues or pull requests. Let's say you've got an open source project and someone creates an issue. You want to have a cool little greeting. Well, there's this nice little action, but you can obviously do more. And when someone creates a pull request, right, send them a message as a comment, like, hey, thanks for your first pull request. And like, whoa, this opens the door to even more. What happens if you have some corporate thingamajig that has a tool, let's call it App Center, that when a bug is reported somewhere, is it the webhooks? I don't know. How do we do this? Is it, somewhere, API tokens? I have absolutely no idea what I had. The services, here we go. You can have it. So, okay, that failed, but there's an option in that box that with someone, when the app crashes, right, it will pop up in the diagnostics. Obviously, I have no crashes because my app is rock solid. Let's go to events. People have run it. Let's say something terrible has happened, and I don't know, an app crashed, right? Something, it'll pop up over here. And then when this happens, you can actually say, okay, make an issue on GitHub. So App Center can create an issue on GitHub. And then when the app creates an issue on GitHub, you now have an event that you can start your workflows, you can do logic, you can notify people, you can do whatever you want in the workflow. So this is a cool way of saying, here's my code and here's all the related stuff, such as issues, pull requests, and all that, the code that runs and the build that executes, all related to your code. And then, of course, you branch out to App Center for distribution or pushing to the store. You're using like some other tool to do something else. You can hook out, and all comes back to what's basically what your app really is, and that is the code, right? Without the code, there is no app. So this is really cool, and I don't know, I'm totally gone all out of whack. But yeah, I hope that wasn't too fast. There's not a lot of time to show off, and this is just scraping the iceberg of stuff. You create a YAML file. There's some events that happen, like when a release is published, or when someone commits to a particular branch. You can have multiple branches, multiple filters, and run some steps. And you literally can do whatever you want. And as you can see with this run, this is literally launching in this case, a Mac OS to shell. So the bash shell. So you can do whatever you want. And sometimes they go crazy. You can use some PowerShell. You run other people's actions. And if you want to look at other people's actions, we go over here and let's just search for Xamarin, because that's what the cool kids are calling it these days. And boom, there's 2 Xamarin Form Android APK. I don't know what this one does, but here's the one I was using, and all sorts of docs and cool things that you can pull right into your workflow right off out of the gate. And if things go bad, you can just make your own, which will happen, and boom, it's the actions are built on like Docker containers and TypeScript, and I think those are the 2 for now. Obviously, times always give us more features, which we like. And here's some TypeScript stuff like, I would like to select some Android, and here's some stuff. So you're using your TypeScript skills, if you've got any, or you can learn some, to create your own action to make your GitHub workflows work even more awesome places. So that was a wild ride. Obviously, here's the docs for GitHub Actions. Basically, let's go to the docs. Here we go. There's a stacks of docs, and I was able to learn in like a week, let's just say. A lot of the cool things, they got a Xamarin app being published to App Center, and it literally is like 5 steps, and 2 of them is check out and set up, and the third one is download the key. If you've got your own agent, then you can have the key stored on a network share. You don't even have to do these 3 steps. You know what I mean? So literally, like, there is no work involved. So and of course, here's some cool YAML file. We've got the full spec out there. There's no need to panic, like, how does it work? Because there's some cool expressions, which I mentioned in the case of the other case over here. Expressions. It's not appearing on the one I want. There it is. You can do some cool stuff. If statements, checks. You can work with a matrix to build multiple things. It's just amazing stuff there. Yes, I think that's that. App Center, we saw that, and I think that's about the wrap for now. Obviously, here's a link to Xamarin if you want to check out what this is. It's free, cross-platform, open source. But yeah, that's just a really quick introduction into all the features of using GitHub App Center. And as you can see over here, I started on UI tests, but I realized that time is not infinite, so I stopped. But basically, you could totally add another step to launch UI tests on Test Cloud. Or let's just go one crazy thing. Let's just say you don't want to spend any money. You open source that app, right? Don't tell Microsoft I'm telling you how to do this. But what you do is you go back, and you search for emulator. There we go. You can run UI tests in your Android emulator without using Test Cloud. Obviously, if you bring your own bot, you can connect physical devices to your own machine, and you don't even need to use Test Cloud. It's just, you could do anything you want because it's a physical machine, not a physical, it's a virtual machine that whatever you do on a normal machine, you can do in the cloud. So why pay someone to do steps when you can get that person to write code, which is really awesome, and then automate the rest. And if anyone makes a mistake, they can catch it before it gets merged to master, so nobody faces the wrath of the red build. So yes, wild ride. I think I'm gonna have to hand over to Allan, because give me another second and I think I have something else to share. So I hope that was cool, exciting, and yeah, let me put the links up here for one last second.
Can I ask you some questions?
Yes.
I see we have some questions posted.
Ooh, questions.
Is it possible to make one build dependent on another using YAML?
One build.
Basically build dependencies.
Yes, I did that. Make this nice and big. Is it library? Here, I put that. Oh my gosh. What a photo. The console app. Needs. There we go. Needs. So basically, I run the build job, and then I run this after. That's why when you saw when I was showing you the page, it did the build job, it went green, and then suddenly the next one started up, because yes, you can chain them all up.
Okay, awesome. Do you need an understanding of Docker before you attempt any of these GitHub actions?
No, not at all, because I didn't use Docker. Docker's when you're really desperate building for Linux. I just use. Yeah.
Okay, awesome.
Docker's an option. Like, I want to build a Raspberry Pi image. Well, you can use Docker stored, so definitely an option, not a requirement. Yeah. Let's get that links. Oh, come on, there we go. Any other questions?
I don't know if I'm allowed to ask you this one, but seeing that you work for Microsoft, what is the strategy of unifying GitHub repositories and Azure DevOps?
And Azure DevOps.
This is putting you on the spot.
Yes. So the interesting thing is, I'm just an employee that's so far on the chain that the information, when it gets to me, it's already reached the MVPs and they've announced it. I find out things at MS Build. But anyway, the process of unifying it, I can't say. I don't know for sure, but I would expect that since they acquired the greatest open source repository, and now with this actions, either run side by side. But I would say, if anything, because GitHub Actions, this is another cool thing about GitHub Actions, is that it's actually running on top of Azure DevOps. So all the software that comes with Azure DevOps and things. So whether or not it exists, it shouldn't bother you, because you can use GitHub Actions and you are running on Azure DevOps. So I don't know what the overall level executive strategy for this is, but definitely I would say GitHub Actions is better than DevOps, because you get whatever DevOps offers plus GitHub Actions, the cool workflow integration of source control. Yeah, but that's I'm not too sure exactly about.
Well, I'm not going to attempt to answer that myself. So that was great. Then the actual question with the YAML is, can you make different YAML files dependent on each other?
Now that you mention that, I do not know offhand. Let me have a quick look.
DevOps might be better.
It might be better, but why would you have? See, this is also the thing with the you have one YAML depend on another, but can you do that with Azure DevOps as well? It's everything is, if you look at my my thing, I have everything in a single massive YAML file, but I have different jobs that depend on other ones. In the case of mobile, like I have iOS build and an Android build that are running parallel. In the case of my console app, they run in sequence. So one depend on another one. The advantage is you have lots of small ones, but in the case of I don't know. I suppose if you want it, I don't know if it is. I can check it up. But in the case of, well, you're based on the job. So do you really need lots of multiple ones? And the one thing, the reason you split it into multiple ones is that you can have separate triggers, if you will, and say like, oh, this just runs on a release and this just runs on a mobile. I don't know if that's sort of what the answer you're looking for. Yeah.
I think what some people do is they version control certain build steps. and then pull them in at build time. They import the templates.
Ah, you mean like templating? I do not believe that's currently the thing. Let's have a look. GitHub. Hopefully my search history doesn't reveal any secrets. I don't think there is templates, to be honest, at this point. I do not recall. I did have a quick look because that's what I use. But then one thing that I thought, at least for an intermediate step until they get it or something, was, let's get to the code again. I used the matrix, which was in the library, which is basically passing in template parameters. So yes, I don't think at this point it has all the features of Azure DevOps. So I'm not saying, go out now, delete Azure accounts and spin up a GitHub account. But definitely for most cases, in the case of our one, let's just go exactly the case of building stuff locally. We have both for right now. So the first one does all the main work on GitHub Actions, and that builds the stuff, runs the test, and does the things. I think that's what we're doing now. And then the final step, we have it run on Azure DevOps as a signing package, because we've got the secret key stores on the VPNs and stuff. So you could even do a dual thing and for a crossover period, because there's no reason for you to say, I have to jump ship right away, because obviously DevOps is going to be supported for the next infinity amount of years. So until now, until they get all the features you're looking for, such as templating, you could do both and just say, on the GitHub side, do all the public stuff if you're doing an open source library, and on the private side, you can do things. So yeah, right at this time, I don't think there's templating, but you don't have to jump ship just yet. Although, give it a go, check to see if matrices work. Maybe you don't need templating. File an issue. There's a place. How do you file issues for this? There's somewhere. There's a way for you to request a feature in GitHub Actions. Somewhere. Where's my code? One of these tabs. There's a way to report, like request features. I forget. There's a help somewhere, and you can say like, hey, give me templates, and the GitHubbers will hopefully oblige. Because I also want to use templates because that's the way my brain works. But yeah, that was a long rambling answer. Yeah. Any other questions?
Yeah, thank you very much. I think we can move on to the next session. Antonio, are you ready?
Yeah, let me get my things shared here. And I shared this one. Cool beans. I think I am live. Oh, I got a background there. Forgot about that. Awesome. So firstly, for those of you who don't know, you can change your theme. I prefer dark. Matthew's white. White backgrounds were really starting to eat into my face.
Matthew, I see you offended a lot of people out there.
And for Azure DevOps, it's the same. It's hidden over. Where did they hide that? They moved it again. Theme right there. I clicked on something. That's okay. Cool. So Azure Kubernetes Services is a pretty cool service. As many of you might have seen, there's been a whole crazy phase going around with the whole Kubernetes service and Amazon launching in South Africa. I think everyone that's into the gaming space has probably seen the local gamers tweet on about servers for Africa as far as Fortnite goes. And I've been giggling on the side because I know Microsoft has had Azure Kubernetes service available locally now for over a year. So Epic Games has had no excuse not to launch here yet. They could have just jumped ship. Anyway, so to start off with, I've got my main resource group, Intro to AKS. And I'm going to show you 2 ways using the Azure portal for this session on how to create basic Azure Kubernetes instances and deploy a basic, very basic, like hello world type of application. So the first approach would be starting without any CI tools and just kind of doing it by hand. And for that, I would recommend using Kubernetes service directly. So pick your intro to AKS. I will explain a bit more around what is happening behind the scenes while this deploys, because it does take a few minutes. So to save some time there, I'll go that way around. I'm going to call this cluster intro to AKS. I keep typing ask every time I try this. And your size. For this example, I'm just going to put down 1 node and a smaller size. So what this is you're actually choosing the virtual machine on which you are intending to run the services that you're deploying. You're kind of choosing the services in the background, because Kubernetes itself is just a host that orchestrates. It's an orchestration tool. It orchestrates how containers deploy, and I'll dive into that a bit deeper as we go on. Virtual nodes. What this is it's pretty cool. It allows you to burst into container instances. So it'll spin up new container instances as you hit load. Or if you're running container instances themselves, it allows you to directly spin into your existing nodes as well and scale out that way. Scale sets, I'd say this is very important to leave this on, and you'll need them if you're going to have multiple pods. And it does tell you that there as well, which is pretty cool. So we're going to have a Linux pool. You can add more node pools if you want to have Linux and Windows machine pools in here. Like you can have Windows and Linux in the same sets of pools. It's pretty cool how they allow you to do that and how you can scale them out. Up next, we have our service principal. So what this is it allows you to control access to and from your Kubernetes service. So you can define what can your Kubernetes service talk to that also exists within your Azure domain. So is it able to pull images from your ACR, your container service registry? Is it able to speak to the different services outside of Kubernetes itself, like app services, and to your Azure databases? Can it directly connect to them, or does it have to connect out to connect back in again? So this gives you space to control that. I'm going to go with a system managed identity. This way it simplifies me connecting to the container registry that I'm going to create. Next, the authentication method, the role-based access control, I'm going to leave this enabled. And this just gives you fine-grained control over what can your service access. Up next, here we define, I'm going to leave this as it is because I don't have a need to change it for this demo, but this allows us to set up the virtual network. So if you're deploying into an existing network, which you can deploy this into on-prem. If you're running Azure Arc, you can deploy this onto your Azure Arc instance as well, behind your VPNs or your firewalls. If you're in the financial technology industry, there's a lot of pretty fancy things you can do. And for this part, I'm going to leave it on. HTTP routing down here, I will highlight. This is quite important. It makes routing easy for us. It's great for a testing scenario, which we are in. It gives us a DNS name to work with. But if you are running a production environment, I would not recommend having this toggled on. And the documentation also recommends leaving it disabled. Network policy gives you the ability to choose between Azure and Calico. Those are tools that are available within Kubernetes themselves. Kubernetes itself to manage how containers and pods communicate with each other. Next, we have the container registry page. From here, you can, if you don't already have one, you can create a new one. So I currently don't have one. I'm going to create one just to show you that it sets up the connectivity back and forth. Registry, and pop it into that deployment group. I'm going to leave the admin user disabled and for the sake of cost, place it on basic. And then container monitoring is an add-on that at this point gets enabled by default. If you do not want it, you can leave it disabled. I highly recommend having it enabled because it gives you an idea of.
Antonio, can you zoom in?
Yeah.
It's a bit small.
It's better. Oh, switching blades. Is this a bit better?
Maybe a bit more.
How's this looking?
Much better.
Amazing. So Azure Monitor, it gives you the ability, it allows your container to report back to the services above it what is happening inside of the containers as far as CPU usage, not the containers, the nodes, CPU usage and RAM and those types of things. It gives you a great overall view of what's happening in the Azure portal. Log Analytic Workspace is where all your logs get stored to. You can choose to rename this, which I personally do prefer to do. I don't like these long ID names here. For me, just relabel them. Looks better, easier to read. Tags, if you're not using tags, I highly recommend them. Tags just, suggestiveness. Tags just give you like great views into what's happening on the billing side of things, and I always highly recommend tagging as detailed as you can. Azure allows you to use tags to target different services to set up policies for governance, and that is quite important if you're in a larger, more enterprise type of environment. And we have passed our validation. We can scroll through to have a check that we've set everything the way we wanted. If we have, then we can just click create. And that's what I'm going to do right here. So creating a Kubernetes cluster depending on where you are, could take a couple of minutes. So while this is happening, I'm going to pop over to a few images I have. I didn't really create slides for this presentation because it's intended to be more hands-on, more practical. So Kubernetes itself, what it is and what it solves is it solves the problem that we have whereby I'm adding more servers to my environment because I need more resources, and setting up and configuring them could take days or weeks if you're in a traditional IT environment. In the modern day, it can take minutes simply by adding this new machine into your pool of nodes, allowing Kubernetes itself to manage that. So Kubernetes is the control plane here at the top. And below it, you have your different worker nodes, which it manages. So you get new hardware, you add a new virtual machine in Azure, or however you want to spend this, you just add that into your swarm or into your node pool. And what Kubernetes will do is it will automatically start to deploy services there for you. You can tag them and control using tags where they are. So some important terms we have for Kubernetes are pods, deployments, and services. A pod is a group, as it says here on the slide, it's a group of one or more containers that share storage and networking in order to form a unit of service. They are always assumed to be ephemeral and co-located. So what ephemeral means is like it's going to die. Like it's not going to stick around. It's like it's going to be reset back to normal. So they're not like pets. We're not going to keep them around. We're not going to like SSH into a pod and do configurations in the pods because they're not going to stick around for very long. A service is how we expose our deployments, and that's pretty much the networking side of things. It's the load balancer in front of it, and it's how we can track what's happening inside of the pods, the life cycles. Up next is deployment. So a deployment, as it says there as well, is just a number of pods running and they are declared in a way. So a pod is pretty much the unit around your service and your deployment. Here on the right side, we have a really lovely illustration as well. Pods are running on top of the Kubernetes API, and this just controls how they're running on the nodes behind them. Next slide is how this happens. So Microsoft manages the security. That's the beauty of AKS, and the maintenance is also handled by Microsoft. The high availability and scalability is managed by them, and monitoring is also maintained by Microsoft. So what we get by using AKS as a service is we don't have to set up a machine, install Docker, and then make sure that we've got all the necessary tools available for Kubernetes to connect to other nodes. It takes away all of that maintenance and management and manual tasks away from us, which is pretty awesome, because in the past, to set up clusters or swarms, you needed to use etcd itself, but Kubernetes has wrapped that up in a really nice way so that we don't have to interface with etcd directly anymore, but instead we can just use Kubernetes itself to do most of that work and just call on a standardized set of APIs through the CLI and manage that. And what Azure has done is abstracted that even more. Microsoft has now given us the ability to click a couple of buttons to do most of those tasks that we had to do by hand in the past. So underneath our AKS cluster, we have a couple of things. Each node is basically a Azure container instance. And in most cases, not for this demo, but in most cases, you have a Azure container registry running right next to your AKS, and you would use Azure DevOps or some other service to push, like Docker Hub, to push your Docker images in there. So for those who might be wondering, you do need to kind of have a grasp on containerization technology like Docker and understand how to build basic images in order to take advantage of what Kubernetes is. And then all of those things run on swarms of nodes that you can choose. You can scale them with a slide and a click of a button. The service principal, this was created, and I already mentioned this. This is your identity for Azure Active Directory. This is pretty much the key to get into any service on Azure, and there's a reason why most people would recommend, and I highly recommend, setting them up in a detailed manner. I normally go in and create them beforehand, but this demo does not cover going through the service principles because there's a lot of things to talk about there. Next is the deployment. So this part here is the code side of things, but the part I want to highlight is this down here. So this is going to be the ultimate where we end up with. We're going to have our node app. In this case, it's going to be a node app, and it's going to be a declared deployment. And our node app is going to be running on a pod in its container, and a service is going to expose that. So the service will expose port 80, but inside of our AKS cluster, the pod itself will be running port 8080 and exposing our container on that port. This image here is directly from the Microsoft documentation, and it's pretty much just a nice way to illustrate the flow of how you would work with Azure Kubernetes service. Here in the upper left-hand corner, we start with us developing locally on our local machines, pushing our code up to GitHub or Azure repos or whichever service you're using. There are some DevOps processes specified to build up your container and push it to a container registry. In this case, the image illustrates Azure Container Registry. And then that will automatically then be recognized using webhooks. Kubernetes will recognize that, okay, cool, there's a new version of the Docker image pushed into this container registry. I'm going to start rolling it out, and you can configure it to gracefully shut down and swap over the containers. What's nice about Kubernetes is it's built to allow you to configure canary releases or rolling releases very, very easily. And pretty much what it'll do is spin up the new pod, first check, is it healthy, is it alive? And let's say this is our running pod and we are pushing a new pod. While pod 2 is spinning up, pod 1 will stay alive and still receive communication via the service over here. It'll still receive communication, and once the new pod is healthy, it'll gracefully terminate connections and reroute them to the new pod and shut down the old pod with the cluster of containers that are contained within them. It can be any language, it can be any framework. If it can run in Docker, if it can run in a container type of container technology, it can run in Kubernetes. And It's awesome. Microsoft is actually one of the main contributors currently to the open source development of Kubernetes, and that gives you great advantages. Using service principals, you are able to connect to SQL databases, Azure Cosmos DB, MySQL, whichever services you can think of. There are ways to connect to it. So let's have a look, see if this has finished. Yes, it is. Awesome. Popping back over here. I'm going to head over to resource groups. I only found out recently that it actually pops up and shows you, if you refresh, it shows you a list of your resource groups. I didn't know that, so well done Microsoft for some beautiful animations there. So what we have here right now is a whole bunch of new resource groups were created. I only created Intro to AKS and this resource group Cloud Shell Storage, which is what I use when I use the Cloud Shell tool itself. The default resource group over here, the MC Intro to AKS demo and Netbook Watcher resource groups, these were all generated and created for us. So in my main resource group over here, what Azure just did is it created three things for me: a virtual network, which I can use to manage traffic to and from my Kubernetes service, my Kubernetes service itself, and the container registry. This is pretty much Docker Hub just on Azure, and it's private. It's your own managed version, and you cannot host images publicly here. So I'm just going to click in and show you guys around. What this has done for us is it's given us the server. This API server address here is just for interfacing with the Kubernetes service itself. It's not for the application, so that will not get you to the application. Node pools over here, we have one agent pool, and it gives me a whole lot of information here, like node count, what type of pool is it. I can add more pools if I want to, and it's a couple of clicks away, and I'll have a new set of pools that I can deploy to. So the purpose for a pool is a pool allows me to define where I want to deploy my application to or my containers to. I can manage that using node pools, and I can up the size by clicking on the button there and just scale however far I want. Luckily, I'm on a trial, not on my credit card, so I can't take this too high, it'll stop me. But this does show me visually how I will now have more cores, more RAM, and it gives me an idea of where I'm going to go to. And my subscription limits me on this one. Or you can set up auto scale, and you can say what is the minimum and what is the maximum. In my case, I can only have 1 to 2, but you can set what is the maximum you're willing to go to, what does your budget allow. You can upgrade your underlying infrastructure or your versions. And what's nice about this is this simplifies things. You don't have to worry about doing it yourself, doing it manually. Like this takes away the manual labor that comes with self-hosting or self-managing Kubernetes. Microsoft abstracts that away and they will do that for you, which is pretty cool. I'm not going to upgrade it now. Okay. Next up is scale. So we've already looked at the scale there, but this also allows you to scale. Well, we've enabled scaling already by choosing multi-node environments in our setup. So this won't allow us to scale here, but instead we scale here at the node count. This will spin up new instances of this machine for us. Networking is pretty cool. You can set up things. So at this point we have HTTP application routing enabled. So this what this did is create a DNS zone for us already, and we're going to make our way there shortly. Next, we have dev spaces. This is pretty cool, and it's a free service provided by Azure and Microsoft to us. And what dev spaces are is I can deploy from my local machine into my large pool of nodes, and dev space will allow me to run an instance of my application next to the production environment and to spin up pods that I can access independently directly within my existing infrastructure without having to pay additional for more resources or for more environments. So this really brings down the cost implications of running Kubernetes and running testing and dev environments, because you can spin them up, limit them, and run them in the same set of nodes that are running your production environment without having heavy impact, because dev instances are killed off when resources are needed. Deployment Center, this is pretty cool. If you decide to use GitHub directly instead of Azure, Deployment Center allows you to set up deployments into Azure using this, and it's pretty cool. I'm not gonna hook this up to anything in this demo, but maybe in a future talk when I go into a deeper dive of Kubernetes, I will set this up for us. Policies. So policies allow you to set limitations on what kinds of ports are allowed to be open, as well as how your node should be secured. So it's currently under preview. As you can see here, both of these are under preview. So this is going to be generally available very soon, but it should be stable enough to use. And this one here you need to register for, unfortunately. What's really cool is governance policies allow you to really configure what kinds of things should be in place for new nodes, for new resources. If you're a financial service provider, this is an amazing way to make sure that people don't create new services that expose existing services, or for example, people I'm working with in Europe, they're using them to make sure that we've got the right monitoring tools installed on all the virtual machines. We've got the right logging tools installed on all the virtual machines, and if they're not present, then the owners of the services, which are identified with tags, get an email saying, hey, you need to do these things, take action. And if action isn't taken, then services start getting disabled. And this can be done autonomously or manually. And over here, we have our monitoring tools. So with this being enabled out of the box, as we deployed it, we'll have a good look at what's our current utilization. Health is in preview, but it's pretty cool. It shows you which of your nodes are healthy, and you can really click in and have a good look at what's happening. And sometimes when there are things wrong here, you can actually have a look at the config of the knowledge base to see what's going on. And these are all the different services. So what's really cool about Kubernetes and running it in Azure is we don't have to worry about core DNS pods or kube proxy pods and setting those up. The Kubernetes dashboard is set up for us. We don't have to worry about metric service, OMS agent, tunnel front, or any of these routing add-ons that have been added, the ACI connection. Like, we don't have to set up any of that. Microsoft did that out of the box for us and manages this for us. We can see what's happening on our nodes here, have a little dive. So currently there shouldn't be much happening here, but each of the services are running, and these are services required to actually keep the nodes and the containers we deploy running. Controllers, again, these are just the actual controllers, and there's a new feature here that allows you to see the live data, what's actually happening, instead of waiting a couple of seconds to see what's coming through. As with web apps currently, it might take 5 to 10 seconds before you see some of the logs, I've noticed. The real-time features that they're adding for live data really gives you a deep insight into that. Logs, this is linked up to the log workbook that we created earlier, and this takes us, let's take this away. Okay, I got it. Oh, it's too small, I can't see the X. This will give us a couple of example queries we can run, but pretty much, I'm just gonna click here. The logbook feature that was added, it's pretty cool. It allows you to have a deep look at the logs happening in the containers themselves. So you can dive in and see what's happening. If you're running your own containers, you can filter them out for the container names. It's almost like writing SQL queries, and it's very simple. I like the fact that this is here, because if you're running, for example, your Netflix and you're running about 3 billion containers, you're going to want to know what's happening in the specific containers you have. I wouldn't want to be hunting for a container and then trying to get into it and see its logs. This simplifies that and gives you a centralized dashboard for most of that. Up next, I'm not going to dive into the AKS registry too deeply, but this is pretty much where our Docker containers or containers get stored. I'm just going to call it Docker, but all of your Docker images, they will go into a repository here. And from here, Azure Kubernetes service can set up links or webhooks more specifically between the different branch tags that you specify in your build repo. These webhooks then allow you to automate a release from here. Then we have the actual infrastructure running underneath Kubernetes. So this group over here is created separately, and these are the services managed by our Kubernetes service. We have our public IP address, which is where we will be able to access the application that is running. Currently, I don't think it's going to give us anything because there is no application running. Then we have our DNS zone. So this was automatically created. This is pretty much our DNS, our website's address. And it's probably also not going to give us anything working right now, which is fine because we're going to release to it shortly. The managed identity is what is used. This is managed by Azure. This is how our cluster, our virtual machine over here, is able to access the registry. The network security group is where we can set up and define access policies, which ports are allowed to be open. So you can lock down all of your ports and even lock them down for regions. The virtual machine scale set, this just allows you to have a set of virtual machines that will be like the same set of virtual machines. So you have a predefined virtual machine image, and a scale set allows you to deploy more of them quickly without a lot of effort. You can just click and slide. So this is how the nodes scale. To give you an idea, so we have our first agent pool here, and when I scale on the Kubernetes side, it's going to add more of them and label them 1, 2, 3, 4, however many there are. Right over here in the scale set. Then we have our load balancer. The load balancer is very, very important. This creates a single point of entry, and depending on where you need to go or how the service's resource usages are, this allows you to choose, well, allows Azure to smartly decide where traffic should go. Or if you set up rules, you can define how traffic should be routed. The public IP address, this is the second one, and this is for our DNS zone, I believe. And then lastly, we have another managed identity. So each of these services, because Kubernetes itself is able to manage and change a lot of the infrastructure underneath it, this service over here, we can manage a lot of the underlying infrastructure because this is a PaaS that manages the IaaS underneath of it. It needs those security tokens in order to do that. That's just a way for Microsoft to make sure that there's no weird malicious things able to access and change any of your things. Everything needs to have an identity in order to talk to the next thing, and Kubernetes is smart. It's not using one identity for all of them. It's using separate ones for each service it speaks to. Our resource group over here is where we have the Insights instance and our workspace. So Microsoft places all of them in a default resource group for a region. That way they're all centralized. If you're looking for logs or for a log instance for a specific deployment that you have, you can find them here. Our network watcher doesn't really deploy any resources that you can see, but it does have alerts and metrics set up for you, or is the place where you would do that. Generally, this is what Microsoft uses it for, and this is where you would set up most of your workbooks and things that manage and watch what's happening inside of your network. So your network being, right, jumping around, your network being this network, where is it? I'm looking past it, but oh, it's because they're placing it in a different place now. This. So the network watcher is where you would set up your different alerts and triggers that would tell you if things are going wrong, if services are going down. You would set up those there, and you can integrate that with external services, or even set up notifications for you. So have Azure phone you and say, hey, you've got nodes that are failing, or things are happening. This is a great way to safeguard your production environment from haphazardous things. Like, let's say suddenly your utilization's on 100 and you're scaling and your services are scaling like never before, and you have no idea what's happening. You'll have no idea what's happening. You're sleeping. Azure will phone you and tell you, hey, your services are busy scaling. If you've set up a watch for that, and it'll notify you that something's happening depending on how you set it up, and you can have a quick look. Like, am I being DDoSed? What's happening? Why is it scaling? Because it could get costly if you're scaling and it's not for business value, or if it's not for business use, it could get costly. But the good news is it won't go down. Takealot had a bad run-in with scaling and Kubernetes. I think about 2 years in a row. They tried to do Kubernetes themselves, and their node pool was their on-site hardware. And when they clicked scale, because they thought, hey, we're getting more traffic, let's just scale, all they did was scale and replicate their pods on the same set of nodes, and they killed it because they weren't adding new nodes into the environment. Okay, cool. So the next part of this discussion is going to be, I'm going to deploy an application and show you guys how to do that. I'm going to use the getting started example that Microsoft gives you. For those of you who don't like Azure Cloud Shell, I'm sorry, I prefer this. It just allows you to really be able to access your shell anywhere in the world from any machine. If you're able to log into Azure portal, you can access your shell. You don't need to set up a new environment. Like, you save a lot of hassle and a lot of effort. So I'm going to create a deployment file and a service file that we're going to use. So Azure store.yaml, and I'm going to copy and paste and explain what I'm copying and pasting in here as we go. So this is a definition file. So what a definition file is, it's Azure's way to, is this thing rendering correctly? Is it sort of is? It's Azure's way to define different services. Something looks a little off. Okay. I don't know why it looks weird, but I'm pretty sure it'll come out correctly when you save it. Yeah, it's just the terminal doing it weirdly. So let's see if I can switch over to VS Code and give you a better look at this. Share. I'm going to stop the share quickly and share again. I'm looking for VS Code.
Real devs
Cool.
use Nano.
Oh, you could use Nano, yeah, it's okay. We've got code live now. So pretty much
Cool.
it's YAML. I've started to refer to myself as a YAML engineer in many instances because YAML is a world of its own. Everything is space sensitive. So what we've got here is we've got deployment and we've got service. So there's two of them. The one is the backend, that's why it's called Azure Vote Back, and the other one will be the front end. This will be the app that we are interfacing with. So you'll see here, this is the specification is pretty much you defining in code what my pods and things are supposed to look like. So in most cases, you can just sort of copy and paste these and take out what you don't need. So in this case, we have containers that are necessary for our application, and it uses Redis. So in this case, we're using Redis in the backend, and our front-end application always doing is it's using Redis to keep a state, because our front end is stateless. And if you're building services for containers, try to keep your front end stateless and rather offload any stateful information or state management, offload that to an external service like Redis. And Azure actually has a beautiful service for Redis that you can just spin up. It's called Azure Redis Cache. And it takes away the effort and the PT behind managing Redis clusters and Redis environments, and handles the updates for you. So you can sleep better at night. So our deployment. This is the definition. This is the actual application that's going to be running. This is our Docker container that spins up, and then our service. A service, as I said, this is me exposing to the outside world the inside application inside of my pod. It's punching a hole and allowing me to speak to the pod, to the container in the pod. And then we have another deployment over here. It's going to go in the same pod, and it's going to define its Redis environment as Azure Voteback, and Azure Kubernetes does some magic here, and it allows you to just communicate between the containers inside of your pod without you having to do too much effort. And if you want to communicate to those containers outside of the pod, you have to expose them. And in this case, we are doing that for our front end and our back end so that me as the client on my side can access the cache, because it would be kind of pointless to have a cache that's not accessible from outside of the environment if my front end depends on it. So I'm just going to spin back to my resource groups. Here we go. So I'm going to save that, and then I'm going to run kubectl apply store.yaml. So this is actually the vote example that they give you in the documentation. I'll share a link to that as well afterwards, and it's going to do most of that. What is it saying? Unable to recognize as your store YAML. Did I make a typo? Yes, I did. It does not exist. Am I mistyping this? Azure. Okay, cool. Let's go. And it's failing to do that. Why would it be failing? Because it's looking for the wrong. So okay, we need to specify and target the node pool we want to use. So get nodes. Can't find it. Okay, oops. Trying to completely switch. Get credentials. Not get credential. From my resource group. What did I call my resource group? Intro to AKS. Wake. And the name for my cluster, which is, I'm going to copy and paste that. Everything is so big. This is my cluster. I did miss a double dash. Cool, so what that does is it sets our context in the shell. That's an important piece that needs to happen. Once that is done, we should be able to now see our nodes in the new environment. Boom, we can see all of our new nodes, and they are alive and healthy. Then what we can do is then just run the previous command that I tried to run earlier. And this will apply and then create those clusters. So let's have a closer look. I'm going to minimize this for the moment and have a look, see at the nodes that should be spinning up. It should take a couple of moments. Well, the pods that should be spinning up inside of the nodes. We should see Azure. I can't remember what it's going to call them right now. That's okay. What I do know is they should be live in a couple of moments. I'm not sure if it's reflecting them yet. Yes, so it should be bringing them up. There we go. Azure Vote Back and Azure Vote Front. So this is the front end. the container that I will be routed to, and the backend, this is the Redis instance running, and that manages the state. The backend is ready, but the front end is not yet ready. So if I refresh shortly, we'll see it should go to being ready shortly. On this side, let's have a look, see if we can see the live data. So I love that this is here now. You used to not really be able to have a deep look into what's happening. I'm not sure how live this information is, but I think it should be live. And refresh it again. It says it's not ready, but let's have a look, see, and refresh our IP addresses. It's always fun troubleshooting during a live demo.
No pressure.
No pressure. Just a couple of people watching and I think asking questions. Let's have a look. See, this should have succeeded. Let's have a preview. Does this show us what happened with the deployment? Nope. Let's go have a look at the logs and see if there's any reason why it would be failing. I would think there's no reason for it to fail, but we can never be sure. So let's be lazy, see if we can see our container logs. Just use a pre-built query. Which one was it? Per namespace. Go. Checking for script. Redis is starting. Okay, this is the Redis logs. Pretty sure the front end one should be there. Checking. It shouldn't be failing. Okay, let's open the Cloud Shell again. Let's get our nodes. The other option was to get containers. I believe it was. Whoops, that moment you're forgetting the commands because you haven't used them in such a long time. One thing I say is it does make you lazy to use the service. It should be working. That much I'm sure of. It was working earlier when I tried it the first time. Let's click on diagnose and solve problems and see if that solves anything. I want to see if there are any issues, reasons why it's not deploying. I'm able to determine, try again later. That's a good one. Monitoring and logging, let's go. No issues, but there should be. Okay, fine. kubectl get service was Azure vote front. I want to watch what's happening here. Load balancer is live. Maybe we're just looking at the wrong IP address. Ha, yes, we are. It is live. So for some reason, it looks like whilst testing it, I did not enable the DNS zone, just being completely frank about that. It did not add it in, so we would need to add our own record set for it in order for that to work. This would be your internal IP address, but I'm going to skip on that. Now the application is working. I can click cats, I can click dogs, I can reset. I can refresh the page and it'll remember that that is the score there, because it is now chatting with the backend, and all of that just works out of the box. Over here,
we need to add some virtual applause.
Yes. Let's see, what IP address should I add here? It's going to be the external IP address probably. Let's go. And I want to route to that. See if I can make this one work. There you go. And now that is also working. I almost feel like people have been clicking on this. Yep. It's public. People have been clicking on it. Cool. And yeah, in a nutshell, that is the basics to using the Azure Kubernetes service. In most cases, you would have this file that we created in the cloud show. You would have that version controlled, and you would run the kube apply commands via Azure DevOps. But yeah, I think I'm definitely pushing for time on this one, and I'll have a look at some questions if there are any. Let's see. Do you have, which one of these are new ones? Okay, thoughts on Service Fabric versus AKS. So Service Fabric is the core to the existence of everything on Azure. Every single software as a service or platform as a service solution you can get is built off of AKS. So I'd say built off of Azure Service Fabric. So I'd say if you know how to use Service Fabric, you can build your own version of AKS. But why? AKS is a free service provided by Microsoft. You don't have to pay for your master node. I know Google Cloud and Amazon does charge you for your master node, so you pay per month for your master node. So your master node is where the actual management tools are deployed for Kubernetes. So by default, you have one of those anyway. On Azure, Microsoft gives that to you for free. Off topic, SpaceX. Any other questions perhaps regarding Azure Kubernetes service, or what else you could do with it or try and do with it?
That looks like all the questions.
Yeah, it does look like all of them. Okay, cool. Until next time.
Okay, great. Yeah, thank you very much. Very cool. Informative, and well done on the demo. We definitely need to add that virtual applause.
Yes, somebody should get an Elgato Stream Deck or something.
Okay, I think we can move over back to Matthew, if Matthew's still online.
Maybe some virtual crickets as well.
There we go. He's back.
Ah,
we
welcome back.
We lost him for a brief moment.
Hello.
Welcome back.
Hi, welcome back.
Let me just yeah, right. Okay. I was just thinking that the whole Azure Kubernetes service is sort of also just taking away all the maintenance of working with scripts to release. The world is becoming more and more lazy developers.
Yeah, before you start, you got a really cool shirt on. You need to make that center of the frame.
Oh yeah.
That is awesome.
I wonder where I got this from. Yeah, I even got the sign badges for those of you who are living in come on, focus for the camera.
Oh,
nice.
Lovely.
Yeah. For those of you involved in other cities.
I think he got that from the MSDUG store, now on the Microsoft store, Who needs Amazon?
Who knows? You have to speak to Allan about the links you get the shirt, or you just got to get involved in the user group. Obviously, not now, and then maybe Allan will throw you a shirt. Anyway, talking about not getting involved in user groups because of unknown reasons, there is this virus going about. You know, some of you may have heard of the COVID. Sounds like some sort of movie, the COVID 2 something, whatever. Anyway, it's COVID-19. I forgot it there for a minute. Anyway, so one of the cool things about not the cool things about the virus. One of the things that's happening with the virus is that it got people thinking like how do we track this? How do we find out? Not in a case of tracking, but how did you as an individual be aware of when you may or may not have been exposed to, in the cases specifically for the COVID virus, but also it's also, I think it's more interesting is like just now another virus breaks out, like we had the SARS and the MERS and stuff. You know, how do we like just get everyone know when you get your infectious diseases, you know, how do you track this and make sure that you are safe? So the systems have been working. The Googles and the Apples have been releasing APIs and products and thingamajigs to basically switch to the right window. They're basically APIs into the operating system, or in the case of Google, the Google Play services, because basically everything is in Google Play services, and enabling sort of tracking and tracing and things like that. And then you can integrate it with a server somewhere by your host local health authority. And then you as an individual, when you get sick or you suspect that you may be sick or whatever the requirement in your local region says, oh, you are sick, please tell everyone that you know, so to speak, quarantine, you can say, okay, I want to be a good citizen. You can send a notification to the server, and anonymously it will notify everyone that you have possibly been in contact with for the last 14 days and in contact with, so if I'm in contact with Allan and Allan's in contact with Antonio over the period of a week, even though I've only ever spoken to Allan, you know, Antonio might get notifications saying, hey, you may have been involved with someone who possibly has come into contact with, so therefore, hey, just step aside for a week, monitor yourself, you know, be aware, you know, don't go cruising in the Alps or something, you may be sick. So in anonymous, tracking this in an anonymous way is technically easy, don't store any information, but also it's hard and people always want to track. So that Google and Apple have been working together to create this sort of a spec, if you will, of how we're going to do this, what we're going to do this, and with the iOS release and obviously Google Play Service has been released, all these APIs are now out on your devices, and now it's up to the health providers, if you will, to say, okay, we're going to create the services for allowing you to track who's come into contact with you. Not when I say track and people, it's not like, oh, Bob met Sam. It's rather of your device is coming to close proximity of someone that may or may not have had some sort of infectious disease. You need to notify the owner of your device to say, hey, you have come into contact with someone that may or may not have an infectious disease, and then that person can respond accordingly. So these APIs, which I'm going to show you now, are actually pretty simple. In fact, I should probably, let's open the Fugit. Yes, let's open the Fugit. Here we go. Let's copy that. It's incredibly simple. So basically, just as an intro of what I'm going to be talking about, it's just sort of the code I've been working on the repo. And if some of you working in the health organizations want to get in on the bandwagon of health and saving lives, you can. It's very cool. Let's zoom in on here. Why it's so small? So basically, this is totally from a developer's perspective of what we did and the services behind it and things like that, rather than the medical side and the details of how the Bluetooth tracking works and stuff. It's more from the, okay, we've got the APIs in the OS. How do I make an app that that basically allows me to track? Let's say you are the health organization. So the API is incredibly simple. In fact, if I click on an expose notification, it's literally just these APIs, because the whole point of this is not to be smart. It's just to be, you know, useful and provide you with the two key informations that you need. A way for you to say, I'm sick, send the data to the server, and the way for you to say, oh, someone near me has gotten sick, that notification back. That's all it needs to be done. No need for GPS. In fact, I don't think Google or Apple will allow an app to go to the store that uses these APIs and has GPS. So very strict requirements. So for the case of is init and is enabled, basically these two are just the status things that don't really matter. Like here's a case of is enabled. This is literally the option is the service enabled on the device. We've got a start and stop for the service. That's literally start the service and stop the service, and this is obviously the state of it. The two other key informations besides schedule fetch, which is basically start a background service to do the last two tasks, and this is where it's sort of really cool how simple it is and how very privacy thingamajigged aware of it is. For example, you are sick, and I don't know where the parameter is. I don't think, no, but yeah. So it's all callback based. That's where it was. I'm always in the other window. Basically, there's two options you can do. If you are sick, you call this method. Basically, your UI can be whatever you want. You call this method, and the system takes control, does stuff, and it calls back into your app. So it's not like it does magic, but the user effectively says, I'm sick, call that, and then the operating system do what it needs to do. And at any random point in time, the system must say, oh wait, it's time for you to get new keys from the server. So I probably should pop up a cool diagram of how the flow works, which I've totally lost. Come on, where's my flow? Let's do that one. Fingers crossed. And it's a PDF. Can we preview PDFs in GitHub? Does it work? Anyway, so those are the two APIs sending in. And while that page loads, the other part, well, let's just look at, before we talk about the actual information, for those who are interested in sharing the exact information, when you are sick, where I'm missing something, version info. Oh, yes, the API does absolutely nothing. I forgot, it's even less. Literally all the information that is shared with the server, the client apps is literally just, first of all, just this byte. And then these rolling intervals, basically, it's not even units of time, even though it's time span, it's really a number of minutes in 10-minute increments, or a number of increments of 10 minutes since the start of time, the Unix epoch. And basically like, oh, you started at 1,000 units and you were together for 3 units, which is 30 minutes. And then that has some calculation in the library that does and works out if you're sick or not. And you can use that to say, okay, it's time to send to the server. And there's no personally identified information. Even this key is randomly generated, and I think that's replaced like every 10 minutes, or at least every day is totally started from scratch. That's a rolling key. That's literally, and this is obviously the information of, all the stuff is literally just the duration and the time stamp, but not actual timestamp, is in the sense of milliseconds. It's more than like, well, we translate it to make it useful, just because it's more useful than having an integer to deal with. But pretty much it's a very simple, and what? I gave it all that time in the world. And there we go. Massive one. There's a flow chart coming up at some point. There's apps. Total fail. Where's that chart? And this is not what I'm looking for, even though there was a chart somewhere else. But anyway, I'm getting distracted by privacy stuff. I'm sure there was interesting. Come on. Work. No, I was here. One of these things. Exposure key, frequent asks. I didn't server. Lost it. I had the page open. Is this it? Contact tracing. This is a cool app.
Is there this is lawnmower behind you?
Sorry?
Is there like a lawnmower? I hear something. Sounds like a mower.
It's my fan on my machine.
Yo.
Is it quite? Maybe I should turn on the headphones.
It's quite loud.
Let's just quickly look that on and see if Teams can switch.
I have this feeling your machine can take off and fly places as well.
That's a serious fan.
Is it there still?
No, it's gone.
It's all good now.
Yay! Switching
No
to
wonder
that.
it's so no. Literally, no wonder it's so cold here in Cape Town.
Yeah, my fan was on. I've got less tabs open than usual, so I have no idea what's going on. I usually have multiple windows. But anyway, so I was distracted by my honestly, notification server. There was literally a graph on every page on how to implement this. I mean, you wouldn't believe how annoying that graph always popping up was, and now I cannot find it. Anyway, there is a graph somewhere. I'll find it eventually. It basically shows that it's totally time based, only for 14 days. There's no personally identified trackable information. And what we have done is bound the APIs, which were cool. And in the case of Android, there was like worker threads and background services. And in the case of iOS, it's special tasks that you had to implement. And we obviously exposed a very, very simple API. And in the case of this particular class, this is sort of the commanding interface. So you want to get the status, you want to initialize it, get enabled. I want to schedule a fetch. I want to start and stop the service, and I want to say, okay, operating system, I want to submit I'm a sick man to the server. And in the case of this one, you say, okay, I want to start the process of requesting keys from the server. So it's pretty much those three APIs. And then when you use that, what happens is the system takes over, it tracks its own information, it calls into the API, it will pop up. In fact, I can show you the cool. I could demo this with Visor. Let's do that. I've always wanted to do a Visor. So basically, the app. There's me talking to myself again. Let's open Visor because it's always cool to show a live touch. Let's make sure I am on the network. And no device is found, which is obviously what a dream situation is. The devices aren't. Technically, you guys can follow along with the cool little GIF that I created last night after like 50 failed attempts. Well, while that loads, if it loads, no, load later. View. So let me talk through this. There we go. The COVID. Let's just launch the COVID. Let's launch the virus, guys. There we go. Perfect. I don't know what state it's in, so I may have deployed it. So here is the cool app. So this is a sample app, which I actually should show the code at some point. All what I'm showing you here is in this repository. So there's no like secret hidden features that we track in your GPS and we're uploading it for Bill Gates to watch on his video wall. Okay, so the app basically requests the user to turn it on, and if I've done this right, this is the operating system, and the same on iOS will pop up a dialog saying, hey, so the app that you're using wants to start tracking stuff, right? Your random IDs and other phones that are nearby. So obviously you can opt into that because that is what the cool folks do. And of course, there's APIs to disable it, which you're not going to do. And that's all you have to do. Now the operating system is going ahead, it's tracking stuff. If I bring a phone near it, it'll be like, oh, this man's a sick man, track him. And I exaggerate there. That's not all what happens. I don't know why I even said that. It's tracking everyone so that when someone says they're a sick man, you have like basically a collection of numbers in your system, and then the server will say, oh, that number is the representative of someone who reported that they were sick. And there's obviously no way, it's just a random 16-byte key. And that way it'll be like, pop up a notification to the user. This thing is getting a little bit sketchy. Pop up a notification for the user and say, you have at some point come into contact with someone who may be sick in the last 14 days. So I've really progressed my life. Let's reset exposures, and I believe. So in the case of me being sick, I would basically go into the app and say like, I'm a sick person. I have been diagnosed, and here's a code I got from the doctor. Right? There's all kinds of doctors, totally doctor-managed system or government or whatever, whoever the health organization representative of whoever storing the keys. And we go in there, submit a diagnosis. It sends your keys, let's say your 30 keys that you've come into contact with people. It sends that to the server, and then the server then begins to process that, and that's it, right? That's all you have to do as a person. And then on the client side, which I can't demonstrate because I have come into contact with no one, so nobody will get alerts. What will happen is, you know what? Let me just even devolve further. Let's launch code, people. Oops, I can't use that one because that's broken. Visual Studio 2. Close that. But while we wait for that to load, let's have a look at code. Let's drag that off. We can actually look at code running in a second. So here is our API. Ooh, little cough. I shouldn't have reported that I'm sick.
What's the exposure?
Yeah, so we have created a cross-platform API to wrap the native APIs, and it's very simple, as you can see. When you schedule a fetch, just ask the platform to schedule it. And we've got some cool features saying like, upgrade keys from the server. And this follows a very simple pattern that fits on the screen. Like, okay, ask the native API to download, ask the user, this is the library we're looking at here now. This is the library. When the user clicks on a button and says refresh keys from server, what's going to happen is going to call this function. This function is going to call directly back into your custom app, which is over here. Again, you can check it out. It's totally Xamarin Forms app, which is awesome, brilliant, 100% shared code except for 3 lines. And basically, all the actual server interaction code lives inside your app. So it's not like the library does anything. The library says, "Okay, app, give me some stuff," and then it'll come over here and says, "Fetch the keys from the server." And this, all you do is, in the case we're looping through the regions, we iterating through here, and basically we in our case we're using blob storage. We're requesting a file. We get an HTTP file back. So there's no magic happening, there's no like advanced function processing. And we get that file, we catch them all. So in the case of, let's say someone has gone to a nightclub and they've come into contact with 100,000 people, right? Because it's a big number. In order to sort of batch these up, the server splits it up into chunks, and they just basically name this 1, 2, 3 because that's where we roll. You request all those batches. So when I say I'm sick, I've come into contact with 100,000 people, it'll batch it up into, say, let's say groups of 10,000. There'll be 10 files on the server. So that's what this is. So there'll be 10 over here. We download all 10. And then we hand that directly back via the where's that line? Where's that line? So this is downloading a batch. It will come right in here and do submit batches. And what this does is this goes back into the native library. It comes over here, so the callbacks for it is that delegate. It basically says, okay, native implementation over here in the case of iOS, send it in. These is literally it's a file that the client could potentially extract and read, but there's just anonymous key data there. But in the case of normal usage, it's just a fat binary file that doesn't really matter what's in it because the server controls the entire thing. You hand that over to the operating system, and then you're done. And then at some point in the future, if the person is confirmed, there's numbers crunching happening inside the library that says, oh, you have been sick. What will happen is it will call back into your API, scroll, and call this. So I think this has like a couple of, I suppose, yeah, that's something separate. There's only 3 members on this interface. Or 4, okay, they get configuration, not important. So there's literally only 3 members that anyone cares about for exposure notifications. So this is an event that gets fired when Google Play Services or iOS detects, you've got a disease, or you could have the disease, or you've been in contact with someone with the disease. And then there's these 2, well, let's start on this one. This one is when you say, I am sick, here's my keys to send to the server. And in the case of when the background task runs every 6 hours or something to check the server, it'll fire back in here, and it will say, okay, it's time for you to process these keys that you got from the server. So it ticks over every 6 hours and says, okay, get your keys from the server, and then again goes to your server, not Google's server. It comes in. This code is out of whack and it's so big my mind can't handle it. So it comes in here, it processes the keys, it fires it off, and if there is an exposure detected, let's take Android for example, it just fires it off, and then some random task in the background will fire it back. Oops, wrong file. It'll come back randomly at any point in time after the number crunching has happened. It's pretty quick. It's like a couple of milliseconds, but in the computer world, that's an infinite amount of time. And it'll come back here and say, okay, here's more detailed information, which again is like more detailed is pretty not cool. It's literally, at a timestamp that's not even actual timestamp. It's in increments. And it's basically you're at risk level 6, which means it's high risk, but you're not guaranteed to be sick, or low risk of like 3. You may have come into contact with someone that was like 3 people away and you were very far away from that person. So the risk is really low. And it's very simple. You pop a local notification. There is no tracking of any information inside the app, because what are you going to store? Random keys that mean nothing to you. It only means something to the servers and things like that, but the server doesn't know anything about the people, so it means absolutely nothing to everyone. So we pop a notification, and that's literally this file is literally the mobile app. So the rest of the mobile app is like 100% navigation, like view models that do like share a positive diagnosis. So let's say I'm sick, I fire this off. We've got some cool little dialogues popping up here. We check, is it enabled? Yes. Let's just say the diagnosis, just in case the network fails. And here we go. Submit self-diagnosis. And that is it. The app itself does nothing. The library does all the work. But the bits that need to talk to a server and track like the data, it's all 100% in this interface. And there's 3 operations, right? Exposure was detected by Google based on the numbers you gave it from your server. It'll pop a local notification. At some point, randomly or by request of the user, you need to update the Google operating system with files from the server. So you again manually download the files. And in the case of you getting sick, or you doctor said going to isolation for some amount of time, you basically say, okay, you press the button, it'll fire an event that will trigger this interface member, and all you do is you basically create a nice JSON object. Here's the literal data of it. It's an app package, device verification. This is what Google to make sure that your device is valid. The platform, which obviously just Android, the regions, which would just be like US or ZA or something, and or it could be whatever. The region is typically recommended country code, but for example, let's say you're in Japan, and who cares about Japan as a whole? There's like 1 billion trillion people there. So like, oh, someone in Japan got sick. I mean, like, what does that even mean? So you might want to break it down into, like in the case of South Africa, a province or a thing like that. So it's all totally up to you. And you pass those keys, which is basically an array of literal 4 items. There's all that the server can, all that Google gives you, and all that really matters. And Google does number crunching on that. And pretty much this file is your app, and the rest of the stuff is hopping all over the place. So if you want to find out more about the COVID stuff before I continue, you just go to Xamarin/Xamarin Exposure. All the links for the iOS implementation is over here. What they track, their agreements, there's so the API, the privacy. What is privacy? There's nothing on this page. Framework API, Bluetooth specification. Like, for example, like what are they? I don't know why there's no link to a PDF, or here's a link to the one PDF of like what they do. Here is the services, their numbers, the things they're using. So you can see that there's no, here's the diagram of the broadcast, which you can check out. I'll zoom in here. It's all about the local cryptography and stuff. And you can check out the code and make sure that nobody's stealing all your secrets or your personally identifying information. And the server side is really, really cool, because let's say everyone in South Africa gets sick, or 60 million, I think is us. Everyone gets sick, and we're all punching in these numbers, of disease-ridden country. It doesn't really matter, because it's all running on Azure services, which are scalable. And in the one case, we're using Azure functions. And the really cool thing, in fact, John created a wiki last night, which might even be server architecture, which is even cooler than showing code at some point. Literally, there is a couple of endpoints. This is for management for the doctor, so let's not look at that now. But there's two jobs really that the client app cares about. The first one is submitting the diagnosis, which was that file of the keys and the device verification. You send that in, a whole bunch of verification, make sure that you are a valid device, and it sticks that in a database, and then that's it. The function ends. It's pretty quick. I can show you self-diagnosis. As you can see, this function is incredibly short. So we get the self-diagnosis object, which I'll show you in a second. And all we do is we make sure it's authorized, verify device. That's basically, we ask Google, hey, you gave us some fancy code. Is this a valid code generated by your device? Yes or no? If it is, we submit to the storage, which is literally just the database that is a, well, it's right now it's a SQL Server database, but you can use whatever, SQLite if you want, storage. And there's no fancy business happening here either. It's the case of submit positive diagnosis. Over here, you start a transaction. We make sure the diagnosis actually is a valid diagnosis. You can type in 1, 2, 3, but it'll fail because it's supposed to be 1, 2, 4. And we basically add all the keys for every region, right? That you said I've been in France and China, and I have ID 6. So update the regions. Most countries only ever have one region, and that's it. You say the changes to the database, and hunky-dory. Then at some random point in time, which is currently set to 6 hours, but if your country is going real bad, you can update it to every hour or every 10 minutes. It runs a job that creates those special files that you don't really understand. It's all about the operating system will do what need be. And this is also pretty cool. It's very simple as well. It runs pretty quickly, and it uses blob storage. We hit up for every region. Where's this now? Make sure region, blah, 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 blah. We get the container. So we create blob storage container if it doesn't exist, just to make sure that we've got somewhere to write to. And then for every batch file, we could just create a batch file, and that batch file, if it's done, we update the regions. But basically, just create batch files. Where I'm looking for that. Create storage. Yeah, so this is scroll up to that quick. So it's pretty, again, pretty simple. All we do is we loop through the items in the database. If I hit storage over here, create batch. So here we go. So we start a transaction. We get all the batch files. We obviously group it in batches of in the case, I think it's like 75,000. Is there a constant there? No, it's in a settings file. So basically, there's a maximum size that each file is allowed to be when you download. That's why we batch it. And say, okay, create a file. And then it comes back in here. There we go, create batches function. Is it? Am I in the right place? Yeah, create batches. So we call that create batches, and then we trigger into this. Basically, so this export is just an object that has a whole bunch of keys in it. Then when we go to functions, and I'm totally didn't plan this one, but we shall see. Signing. Wonderful, because we like to use things. It's signed with some cryptography keys, and it's pretty simple. It's a zip archive with 2 files. The first one is literally just the protobuf of the object, which is literally like, I can show you the protobuf. So it's a protobuf with the binary keys in a list, and then it's signed to make sure that no funny business is going on in the case of like a repeat submission or replacement, or someone has gone in and added random numbers. So it's signed with the private key that your current server hosts. And yeah, basically it's like, this was more complicated when I was writing it, but it looks so simple now. Basically, we add signatures to the file and zip streamed it up. It's like, well, nothing happens anymore. It's code. It's like, so it's basically there's 2 functions. I mean, that store it in a local database, and all the data that's stored. Here's the proto file, which you can check out as well in the proto folder. Where you see exactly what is transmitting across the wire, what data is stored. For example, here's the signature algorithm, the Android package ID, which is thing, and here's the exposure key. It's literally key data, risk level, rolling interval number, and rolling interval period. I mean, there's nothing there, no Bluetooth information, no people's names and numbers being tracked. And yeah, those are the two functions that like they don't do anything such. And the cool thing is it's literally just users according to the thing. It's like the blob storage and Azure functions, and you could use SQL Server. That's probably like recommended. You could use an in-memory database, or you could write it to like what do you call that? Cosmos DB, or like a SQL, well, yeah, whatever, Redis cache, that sort of thing, something. And basically blob storage. This is the database schema. It's two fields: the diagnosis UID, which is what the government/health organization will give you, and this is the information stored per item. There's like two tables, so there's no information stored, and the app is literally this exposure notification, because the rest of the app is just talking between the two, and you control. This is a complex download logic, but it just you talking to your own blob storage, you talk to your own functions, you're talking to your own stuff. So there's no operating system level integration. It's like, we got the data, deal with it. And then you obviously write your code in your app to deal with it. And then you say, okay, I've got some stuff back. Can you check to see if I'm sick? And then the app does something, or the operating system does something, and it pops up another notification saying, you possibly infected. And I've probably been talking for like 20 minutes on stuff. Let me pop that link slides while I transition to stuff. I don't know if I was just going through everything. No actual agenda. If anyone's got something they want to check out, first of all, there's the links over to the GitHubs and the Apple Docs. And if there's any questions on how do we do something, what do we do, or whatnot, I don't know.
It's actually very interesting how that works.
Pretty awesome.
I don't see any questions yet. Everyone's speechless.
Yeah.
But while we wait for questions, we missed your shirt on camera.
Yeah.
So I'm going to ask you, let me just put you fully on camera.
The badge of honor.
And wait for it. Okay, now you can do some modeling.
That is muscles.
That is a really cool shirt.
This is Johannesburg. Hello there. We're thinking of you. Stretching to Durban. Look at that. Cape Town, obviously big and powerful in the middle, because we all know that's the greatest part of South Africa. No offense to all of the ghetto people. So that was like a wild ride all over the place. Check out the Nougat, and if you are government, check out our stuff. It's better than you could possibly imagine. We even got unit tests. Oh, and this was the one that was running on the Gits, on the GitHub Actions as well, which is like a total example. It's nothing to do with the actual, as you can see, the build fails there. Don't look at that. Basically, here's our thing: it's like when a release is published, run a build and just make sure it's all good. On a pull request, on a push, and on a tag. Look how simple this is. You can add this to any repository and just check to see if it runs. The whole actual release is on a separate pipeline somewhere else to make sure we sign out nuggets and stuff. But yeah, so when you commit, it'll tell you you've done a boo-boo. Let's see what the issue is. Yeah, but if there's any questions on the build fails with the test runs, what does it mean?
Oh.
Yeah.
Well,
Nice.
Reminds me of a meme I saw in the week when all your tests pass, but the app crashes.
Run all jobs. Let's do that. It's a sharing violation. Who knows what that means? So I hit run, run again, and it's going to go green.
Sharing violation. It knows you're sharing the screen.
Yeah. Oh, that was green yesterday, and then I changed a config file, commit directly to master. Now it fails. So I've been blamed, but I'm now going to redeem myself with the dot. Yeah. So cool example of functions at work. I don't know. Oh, back to Allan, I suppose. How they can lead us.
No questions so far.
Well,
So,
I see an interesting question.
yes.
And I'm going to share a link to the solution for that. It's on my GitHub, but it's how do you stop all the Docker containers that are running if you do like a Docker PS or a Docker containers show command, or well, Docker container list command? How do you stop all of those containers at once? This is a little bit of I'm not sure if the person is using Bash or PowerShell, but it's just a little bit of like shell scripting to list them and grab their IDs and then run a stop command for each. I'll share a link to my GitHub where I have a command for that.
Cool.
Yeah. Question that we have for the people: will you install an app to help your fellow man? Are you scared of the tracking? Don't have to put your answers in the chat. But people are like, some people are like, nah, not gonna let them track, not even a random number. They're gonna hunt me down or something. Yeah.
It doesn't look like anybody would.
See, the boss was also on the chat. Hope I did him proud, because he sent a link to the graph. Let me see if I can show that the actual steps that this thing takes to track what it tracks, how it tracks the communication. Which app was that? That was the Slack. Let's see, I'm opening another Electron app, guys. You're going to hear a loud scream as the fans roar to life. We could see the actual, where is the John, there we go. COVID app, current tracing. Yeah, this is, the docs from Google, and I think this is, yes, they had the graph here. Here we go. Let's zoom in. So those who are interested in seeing, like, how does the flow go? Oh, it's so small. Basically,
yeah, can you zoom in on that?
Let's just go to the top section. That's the scanning, process, and diagnosis. Let's zoom in, which is pretty cool. Oops, it scrolled across. I would have had separate charts, but looks like a tiny chart is what Apple went for. Yeah, massive scrolling jumps. Oh, if I had a touchscreen now, I could have fine control. Obviously, my external display does not. There we go, hands off. Yeah, so this is the advertising. So when you walking in the streets, you're doing your business, everyone's got the app on, tracking their stuff, and this is the flow. So I think a new number is every 15 minutes elapsed. That's what the 15 minutes delay, and every 24 hour they derive the key from the tracing key. Yeah, the Bluetooth tracks numbers, saves the rolling identifier, and then it continues the loop. Get a new proximity identifier and say, hey, I'm here. So that's why it's like every 15 minutes for the same one for 15 minutes. So if you're walking down the street, unless, and it's like totally random anyway, there's no time stamps as such tied to it exactly. So you can say, like, well, I came into contact with someone in the last 15 minutes, and if you're really going to track this information, it's like, well, okay, then what about you walk past someone's house and that guy was in his garage? You know what I mean? Who was it? The chances are you can't even track that, and it's random UIDs that they're totally refreshed every day. So it's like, who knows anymore? Then once that all gets tracked, and let's say, what is this, scanning? Scan for connection. Well, save rolling proximity. This is, I forget. See explosion detonation. Oh, is this when? Wait, get tracing. No, this one is. Forget what this advertisement does. Scan. I forget what saving does. Oh yes, the periodic keeper. So we save some stuff and then we request things from the server and we feed it in to the API over here. And I believe this is API column, the Bluetooth remote and the crypto remote. Feed that nice into the API, and then they do some algorithm to assess the risk, and then it pops back in access, time, duration, your context. What? And then what is this next? This. What? Ask for permission. So many pop-ups. Never really did understand this diagram. I'm just the grunt on the floor, to be honest. Got the boss to do the hard work. I wrote code. Yeah. So
that's quite a diagram. Sure.
Yeah.
Okay, it doesn't look like we have any questions related to this. So thank you very much. That was awesome. So let's start wrapping up.
Okay, how do we cancel this? I'm going to stop presenting. Let the Pead take over.
The Pead is on it.
Matthew has an incredible
Okay, thank you very much for everyone that attended. Hope it was useful. Just something to note, SpaceX's first manned mission is tonight. You can watch it live at this link here. I hope it all goes well, but it should be really interesting to watch that. So something interesting to keep an eye on. And yes, thank you very much for everyone that attended. If you're interested in speaking and contributing to these user groups, please contact us on Sessionize. And everyone has something interesting to say. Even if you're learning something, those are always interesting to see technology from somebody that's learning's perspective. But yeah, thank you very much. And thank you for spending so many hours with us. And yes, have a good evening. Anything from Matthew? Antonio?
I can hear him smiling now.
You're very soft.
Thank you everyone for joining.
Well,
yeah,
thanks for coming.
Thank you very much for being speakers. It's really good. And see you all next month.
Cheerio.
Cool.